Hey guys, Mr. T here on your next video. This is on random sampling and should help you with exercise 9.2. So we've already talked about in sampling how you want to avoid bias in your sample. So you need to make sure that the sample is randomly selected, and that means every member of the population has an equal chance of being selected in the sample. So there's three main methods that we're going to cover for random sampling in different situations. There's simple random sampling, systematic sampling, and stratified sampling. So we're going to go through those one at a time. So simple random sampling, you're going to use this when the population is available from to sample from all at once. So you have the population there ready to go, and you can get your sample while they stand there or while they're sitting there. Okay. In this kind of sampling, simple random sampling, members of the population are selected randomly. It could be out of a hat, out of a barrel, or using a random number generator. And you select them randomly until the sample size that you've chosen is filled. Now you can do this yourself, maybe for the DI, using the randint function on your graphics calculator, and assuming that you've numbered the population members as well. It's not going to work choosing random numbers if you haven't numbered the members of your population to begin with. So how do you do that? Grab your graphics calculator, press the math button towards the top. At the top of the screen that pops up, you'll see a bunch of tabs at the top. So move to the right to select PRB. Then you'll see a menu come up. Scroll down to 5 randint bracket and press enter on that. And randint appears on your screen with a little cursor flashing there. Now what you need to enter after randint is the lowest number that you want to randomly select between, the highest number you want to select between, and then the number of numbers you want to be randomly selected, or in this case you'd be looking for a sample size. End the bracket, press enter, and you use the comma button to separate between those numbers. And when you press enter after you've entered all that, you will be given a set of numbers the size of whatever you said the sample size was, and they will all be randomly selected between the lowest and the highest numbers that you set. So I'm going to do that as well. I can't show it on the screen because this is on the iPad. So I'm going to open my graphics calculator. I've got randint there. I'm going to set my lowest number to 1, comma, highest number to 100, comma. I shouldn't have entered this. Sorry, I set an example. I want a sample size of 10 from a population of 50 people numbered 1 to 50. Right, so it should be 1 to 50 because I'm going to number my population from 1 to 50 because there's 50 of them. So I'm going to press math, go to PRB, scroll down to randint, and so I'm going to number my population 1 to 50. So I want to select random numbers between 1 and 50. So I've put randint 1, comma 50. It looks like this. 1, comma 50, comma, and I want a sample size of 10. So the last comma after that, I'm going to put 10 there. End the bracket and press enter. And when you press enter, what do I get? I get a set of brackets that say 17, 50, 11, 40, 48. I can't see the rest of them, but you get what I mean. There'll be 10 selected, so I'll have to look up how to see the rest of them, but that's just an example. They're being randomly selected. Obviously yours will be different to mine. Mine just went off the screen, so I need to work out how to scroll across, but that's just an example of using randint. Alright, systematic sampling is the next kind of sampling you need to do. Why is this different? It's because you're going to use systematic sampling when the population is not all available at once and instead are coming in over time. So, for example, people shopping in a grocery. You're not going to ask everyone that shops at Marion to stand there and sample them, okay? They're going to come when they're available. And so when you're doing systematic sampling, you're usually going to express it as, I want to take a something percent systematic sample. So what you use is k over 100, whatever that percent is over 100, to determine the interval of the population that you're going to sample. So however many, every whatever number person. that you would select is the interval, and then you'd also use rand int 1 and 100 over k to find which is the first member of the population you're going to sample. So I want to use this example here. I want to use systematic sampling to sample 5% of the customers entering a shopping centre. So k over 100 is going to tell me the interval. I want 5%, so it's going to be 5 over 100. It's going to be 1 over 20, therefore every 20th person, or 1 in 20 people, are going to be sampled. But to make sure everyone has an equal chance of being selected, you need to randomize the first person that you choose. So you would go rand int 1 and 100 over k, which was 5. And that's the same as rand int 1 and 100 over 5 is 20. So if you wanted to randomly select the very first person to make sure that you have a fair sample, you would go rand int 1, 100 over 5, which is 20. And on my calculator, that came up as 1. So I'd be sampling the first person, and then I would be sampling I would be ignoring everyone until the 21st person. So every 20 people after 1, you would be sampling and putting into your sample size until it's full. Okay, so that's an example of systematic sampling and how you would apply it. Then the last is the most complicated. Stratified sampling is sampling you use when a population is already divided into subgroups, which we call strata, and you want to make sure each strata is represented according to its size in the population. So the only formula you need to use here is strata size over population size. Find the answer to that, then times it by the sample size. It'll tell you how much to include in your sample from a particular strata. So why is that important? Well, it will become important in this example we're talking about here. Let's say we're talking about preferences for uniform in a particular school. You're going to have different numbers of kids in different years. So you're going to be using stratified sampling here because you don't want any of these groups to be overrepresented based on their size, but you also want them to be fairly represented based on their size. Here you can see the smallest group is the year 12s. You wouldn't want them to form the largest part of the sample because they're not the largest part of the actual population. Okay, so an example of applying stratified sampling we're going to do here using that formula. So you have a school of 137 year 8s, 152 year 9s, 174 year 10s, 168 11s, 121 year 12s. And we're only selecting a stratified sample of 50 students. So we're only going to choose 50 out of all of these kids. But we want to choose a fair sample that's stratified, and we want to choose the right number of people from the each year level. So from year 8, we need to apply that formula. So the strata size, there's 137 year 8s, and in total, if you totaled all these numbers up, it's from your book anyway, there would be 752 kids in total, times by the sample size that we're looking at, 50. 137 divided by 752, times that by 50. Goes 9.10, so we round down to the closest whole. It would be 9 students from year 8 in the overall sample. Year 9. There's 152 year 9s out of the 752 kids, times it by the sample size of 50. 152 divided by 752 times by 50. That comes to closest to 10 students. Year 10, there's the most, 174 out of the 752 students, times by the sample size of 50. That comes to 11.56, so the nearest whole is 12 students. Year 11s, there are 168 year 11s, 168 out of the 752 students at the school, times by 50. closest whole is 11. And then finally year 12s, 121 year 12s out of 752 times by 50. And the closest whole number is going to be 8 students. And so when you're doing this, sometimes you need to round to the closest whole, but you do need to double check that that actually equals the sample size. 9 plus 10, 19, 20, 21, 31, 32, 42, 48. So there's 50 student. Yes, we checked it. There's a 50 student sample. And this sample will properly reflect the size of each strata. So the lowest number of kids in a group is the year 12s with 121, so they have the lowest number of students in the 50 student sample. The highest number of or the largest year level is the year 10s with 174. They make up the largest portion of the stratified sample of 50. So that is an example of using simple random sampling, stratified sampling and systematic sampling. Hopefully that helps you out. Sorry about the little scrolling mistake on the calculator before. I couldn't see all of the 10 random numbers, but you can see it on yourself. I'll try and sort out how you find those on your graphics calculator in class. So yes, hopefully that helps you out, and I'll see you on the next video.